All right, so starting the live stream, this is just a test to begin with. So just so you know, we've never done this before. We've got multiple camera views, we've got 24 students in class, and so we're going to see how this goes. Okay. Today we're going to be covering the motor. We're going to cover a few things. Let me switch views here. Okay. All right, so we're going to talk about motor and sensor setup for one motor, one line tracker. A couple other things we're going to do, we're going to define variables. We're going to do the setup, we're going to set up some functions, or at least one. We're going to run motor, that's going to be one of our functions. And then we're going to use if-else statements. Everybody should have a Dell computer with Windows on it, a Cortex, a battery, an orange USB cable, a line tracker, and a motor. And so we're going to use all of that stuff. Okay, so before we go any further, does anybody remember what variables are? Yeah.
Variables are where you can make it where, say you want to do power 1.7 instead of running at 1.7, you can make it full. Or you can type the power out.
Okay, so you could set up your own like names of things that you want. All right, good. Any other definitions or ideas about what variables are? Okay, that's one of the things we're using it for. Variables can store information. So for instance, you could say that a variable of a number could be 1, and then later on in your program, because you could say that the variable equals the variable plus 1, and so then it would equal 2. And then later you could say the variable plus 1, and it would be 3. So there's a lot of different things you can do with variables that we actually haven't gone over too much, but we're really using it for basic things. Okay. What about functions? Does anyone remember what functions are? Let's do somebody other than Peter. Riley, do you remember? No? Okay, Sarah.
Functions are when you void a task with the command void, and you describe what you want that task to do, and then you can have it put input in your code, and it will do that task without having to rewrite the code multiple times.
Right. So in RobotC, we use the term void, and that actually is a way of specifying that it's the type of function that doesn't output like a traditional value. So we're really just using it as a kind of a copy paste, if you will. So you can put in lines of text, lines of code that you want to refer back to several times, and that way you don't have to copy and paste all that code throughout your program. So it can be really convenient to use that. Also, we can specify within the function, and if you haven't watched the advanced video on this, then you're going to be doing this for the first time today, where we can give a variable with the function. So we can have a function and then a variable inside that function, and so we can make our function a little bit more powerful. So we can use, not only can we use it as like reoccurring text or reoccurring code throughout our program, we can have it do something different each time. So we're gonna see that, how to do that also. And then we're gonna use if-else statements. And so if-else statements, we'll all here by raising hands just watch the video on if-else statements. Okay. Yeah, because I can tell my YouTube views are not that high on that one. So you might want to watch that tonight. Remember, we do have a summative test on Friday, day after tomorrow. Okay? So make sure that you pay attention today. Hopefully this recording will be on YouTube and will show up okay. So it is showing up? Awesome. Okay. And hopefully the audio is not all funky or whatever. So if this works, then we might do this more. It'll be cool. Okay, so that's what we're doing. Everybody should have all this stuff. Is everybody ready to kind of start getting into the code? You need a motor. Craig, can you get them a motor?
You have a motor?
Oh, it's hooked up to the wheels. That's
We need
true.
a motor.
Okay, they need a motor? Okay. Everybody has an orange cord, a Cortex battery, a line tracker. did? Yeah. Oh, it's delayed? Yeah. Okay, so you should have a line tracker. It looks like this. Like that. It says line tracker on it. All right. So hopefully everybody has RobotC open now. And there we go. Oh no. All right. On your computers, you're not going to use the Citrix server. You can if you want to follow along on your Chromebook. You can log into the Citrix server and do that. Otherwise, make sure that you can see one of the Dell computers that you have and you have RobotC. If you open the graphical one, make sure you close it and open the right one. Okay. Let me go to the desktop here. This may take a few minutes. So I had the countdown off. It said it was still starting in 2 hours because I had scheduled the live stream, so it was wrong. Taryn?
Yes, sir.
Oh, I'll have to fix that. Okay. Make sure you click for a new file. Okay, we don't want anything existing there. And go ahead and open motor and sensor setup. We'll get you started on that. What should we call our motor? We're going to call it Bob. How about
Yay.
Bob the motor? So, are we going to use camel case for that? Because in our name of our motor, we're not going to have any spaces, right? So, you could do capital B, OB, and then capital T, HE, and then capital M, OTOR. Makes it easier to read because there's no spaces, right? Okay? We call that camel case. Wow, my computer's being really, really slow. Okay. Not the graphical one. Okay, finally. So now on a new file, you've gone to motor and sensor setup, and we're naming motor, and let's just put it in port 1. We'll call it Bob. Bob the motor, okay? And it doesn't really matter which kind of motor you select for our purposes today, but I'm going to say 269 motor. Say OK. Now I have that in there. Oh, we need to set up our sensor now. Okay, so there's analog sensors and digital sensors. Let's just do a quick recap. So let's see, Gracie, can you tell me the difference between a digital and an analog sensor? No? Do you remember how we talked about the lights? When we talked about the lights, where the light needed to be, this light switch could either be off or on, and if you had like a dimmer switch at home where you turn it and the lights dim, fade up and fade down, or sometimes they're like this. Guys, let's turn our audio off, okay? Do you remember those two different ones and how one of them was digital and one of them was analog? Do you remember which was which? You've got a 50-50 chance here. You want to take a shot? No? All right, Delaney? Digital is on and off, so then the other one would be analog. Okay. So when we're looking at switches, what would be a bump switch, JoJo? Right. And so would that be digital or analog? Absolutely. Good job. Digital. Why?
Because you can't press it like a little bit and then have it a little bit.
Exactly. It's either on or off. You can't just push it a little bit or anything. Exactly. Perfect. Okay. Really good. Does anybody know what a potentiometer is?
That's that. Like it's a red thing with a hole in the middle.
And it turns, right? Okay. So it's the same thing. It's actually what is used for those dimmer switches. Where you turn them, they're almost exactly like the potentiometers that we have. So they're also analog. What do you guys think about light? Is the light either on or off? Can you have a little bit of light? Can you have a lot of light? So do you think that a line tracker, do you think it's going to be digital or analog? Yeah, it's going to be analog. you could have, I guess, something that was digital. It's either sensing light or not, but it's probably going to be analog, okay? So under analog sensors, then we're going to put in, let's put it in analog input 1. What should we call our line tracker?
Bob just needs it.
Terry the tracker?
Yeah.
Terry the tracker. And it's very important under sensor type, you need to specify line follower. It'll work a little bit different if you choose line sensor or, light sensor or analog or whatever. So for what we're doing right now, we're going to just choose line follower. Okay? Were there questions? Did somebody have a question? Okay. So click OK. And I want you guys to start getting in the habit of kind of clicking compile program anytime you make a change. Okay, so with the compile program, make sure that there's no errors. Doesn't look like it's compiling. Not responding. Okay. Of course, we have technical issues today. What?
What should we call
Our file. Oh, whatever you want. So let's just put, when you name your files though, I think what we're going to start doing is the computer number that you have, you can take note of that. And so if your group is using computer number 4, then you can use computer number 4 again next time. So just put your file when you save it as like your last name or your group name or something that you'll be able to know that everybody in your group will know. Okay, that way if the next time you come in, if somebody's absent, it'll be there, okay? All right, we're probably still going to do some stuff on the Chromebooks as far as where you write the code and everything. Your test on Friday, you'll be writing the code on RobotC on your computer. You're going to have a limited amount of time to do it because it's during a class period. And you're going to write the program. You're going to take a screenshot and you're going to submit it to me. You're also going to submit the .c file that RobotC spits out. Okay. I'll have all kinds of instructions ready to go for how to do all that stuff, but the program will be what you're going to be graded on. Yes, sir.
What are we going to be coding?
What are you going to be coding? Yeah, that's what you're going to find out. That's going to be the test. So it's going to be very similar to what we're doing today. Okay. All right. Good. So it looks like it came up. It wants me to save it. I'm just going to save minus that. Okay. So it compiled without any errors. Not surprising, right? Because we didn't have anything in there. Okay. Okay. The first thing I want to do is write some pseudocode. Remember, pseudocode is just fake code that we use to put in kind of our own words, but also still kind of like programming. We don't have to worry about commands or syntax or anything like that. This is just going to be something that we're going to read for us or for anybody else who looks at our code to know what it's supposed to do. So our code today is going to run a motor if a line tracker sees light, and then we're going to try it the other way around. So like if it doesn't see light, okay? So that's it. Pseudocode doesn't need to be super long. Just, give an idea. And we'll also make sure that we do some comments, okay? You really can't do too many comments or too many notes on your code, right? If you want to think about it, like if you were to give your program to somebody who's never seen any programming code before, would they be able to figure out what your program does?
No.
If your notes were good enough, they would, right? Okay. No, that's a good point. See, that's the point I was trying to make. If you don't have any notes, no, they wouldn't know, right? Okay. All right, so the first thing I want to do is I want to define some variables, right? That was the first thing we were going to do. So there's a couple of variables that I want. I'm going to set up an integer that is going to be the motor speed. And that's going to be, I'm going to set it as our maximum speed, which is 127 for these motors. So INT motor speed equals 127. And then I'm going to set up another integer called threshold, or you know what, let's call it light threshold. Okay. And we're going to change this in a second. So right now we're just going to put in kind of a placeholder of 2000. We'll talk about that in a little bit. Okay, so our light threshold will be 2000. We'll have a motor speed of 127. And I think that's all the variables we need for right now. Okay, so then I'm going to say compile program. Okay. Remember those gray X's? If we read down there, it's saying, hey, you have these variables defined, but they're not being used for anything. That's all it means, so we can ignore those. And then I'm going to set up a void function. Okay, so I'm going to type void. And then I'm going to name this function run motor. Run motor. And then I'm going to put 4. Run motor 4. Okay. And make sure you do your opening curly brace. Now this is, sorry, I messed up here. Okay. This is something I want you to start doing. When you put an opening curly brace, I want you to go ahead and put the closing curly brace. Just like that. All right. To know that anything in here, that's the code, is between those curly braces. The program doesn't care about line breaks. It doesn't care about spaces. Okay, those are for us. Yes, sir. Okay. Okay, so it's void. Did you get the variables? Okay. So the variables are INT, motor speed, equals 127. And then INT light threshold equals 2000. I can change the font size of this, I think. No, motor speed and light threshold. Light speed, that'd be a cool one. Font increase. Control plus. Yeah. There we go. Okay, so I see motor speed. Can you see it now, Rashad? Yes, no? Okay. We check on the stream real quick, see how that's going. That says stream health is healthy. Cool. You guys chatting in here? Doesn't INT stand for integer? Yeah, INT stands for integer. Okay?
Childish just says that like blah blah blah. I like cheese sticks.
Okay. All right. So now, all right. So now for the function, I am going to put some line breaks in there so that I can write my code in here nice and comfortably. Okay. It's okay to stop me if you have questions. How are we doing, guys? Okay. Okay. I'll slow down. No, I got it. So, where are you at, Delaney? You did the motor and sensor setup? Okay. You added the two variables? The INT? Yeah, okay. And then you have the function started the way that I do? Void run motor 4. Okay. You guys good? You guys good? Good? Raise your hand if you're a little behind. It's okay. Okay.
Drag it back on.
The what?
The stream's a little wet.
Oh no, not the stream. The where you are on the code. Okay, you good? You good?
Why does it have like the
Okay, so the little X's, what color are they?
They're white.
They're white, or they're gray, or they're white?
Yeah.
Okay, if they're gray, if you look down at the bottom, it's telling you the line number. Like on mine, it says line 10, and there's a gray X that says info. Means just, hey, just for your info. Motor speed is written, but no read references. That means that it's not being used in your program yet. You're just saying, hey, motor speed is 127. But they're like, okay, that's cool, but you're not using that anywhere. So we can ignore those X's. Yes.
We have what? What are your red X's?
Okay, you got some red X's. Check your punctuation. Make sure that you have your semicolons. Make sure that you have it written exactly the way that I have it on the screen.
It says that on line 19 or
You might have different lines, remember, because I did pseudocode and everything. Not everything has to be on the exact same line. Okay? All right. We ready to keep going? I want to do one more step, okay? Remember, this is being recorded. Let me do one more step, okay? So, now that we have run motor 4, that's going to be, we're going to say start motor, okay? And what motor are we going to start? We only have one, right? Bob the motor. And then how fast are we going to run Bob the motor? For motor speed, right? We set that variable up. And that way, if we run Bob the motor, if we run him in more than one place in our code, then he'll run for motor speed. And then later, if we go, wow, Bob's running too fast, we want to slow him down everywhere in the program, then we can just change that one variable, right? We could just go up here and we could say, let's slow Bob down to half speed, and we could put in 63, and then everywhere in our program, it would change. That makes sense? Okay, cool. So we'll do back to 127, okay? All right, so we got Bob the motor running at motor speed, and then we want to wait. Let's just put in 1 second. Okay, and we don't really need to put stop motor in there, but I'm going to go ahead anyway. I'm going to say stop motor. We tell Bob to stop. He's good. Okay, so while you guys are catching up on that, I want to talk about how we can use this function. How we can use this function to run the motor for different or varying number of seconds. Right now, the way we have that function set up, what's going to happen if I say run motor 4? Yes?
It'll run motor at 127.
Yes, it's going to run the motor at 127, but for how long?
We don't know.
We don't? 1 second, yeah, exactly. We said wait for 1 second, so start motor, wait for a second, and then stop the motor. Okay, so it's only going to run for a second. But what if I want the motor to run for 2 seconds? I could change the wait time, but what if I want the motor to run for 2 seconds in one place and 4 seconds in another place?
Could you just add another motor and you program that motor to split like for 4 seconds and the other motor?
Set up another motor, I guess, maybe depending upon your application. But I'm going to show you how you can set the function. You guys listening? I'm going to show you how you can set the function so that you can input the amount of time every time you use the function. Watch this. So when I say run motor 4 and I have those parentheses there, that's for a condition. we don't have a condition defined, so that we don't have to put anything there. But I'm going to go ahead and put a condition there. I'm going to say to assign the value of a variable. Now, when we do seconds in RobotC, sometimes we could do what? 1.1 seconds if we want. So if that's a decimal, then we don't want to use the variable type of integer. We don't want to use integer because an integer will ignore the decimal, right? So if you had 3.5, it would probably round to 4. If you had 3.4, it would probably round to 3. All right? So what we want to do is we want to use a floating decimal, and so the term for that is float. So just like int, you're specifying a variable type. We're going to say float, and we're going to just call it seconds. Float seconds. And now down here where it says wait, I'm going to put seconds. So what's going to happen here is when I use this function, I'm going to say run order 4, and then in parentheses, I'm just going to put the number of seconds. Then when it references that function, it's going to look and say, okay, run motor 4, and it's going to see the number you put in there, and it's going to say that that is seconds. And then it's going to say start motor 4, or it's going to say start motor. It's going to run Bob the motor for the motor speed. And then it's going to say wait. It's going to say wait for how long? It's going to say wait for seconds. So what seconds? It's whatever you specified that time around. And then later, if you do that function again and you say run motor 4 and you put in parentheses 10, then it'll run it for 10 seconds. So this can be really powerful so that you can really utilize very more advanced pieces of code in several different places. Okay? So now we have variables set up. Yes, ma'am.
What's your name is your keypad? And we got some red X's.
I'm sorry, what was that?
We have some red X's in our
Okay. Peter, do you guys have any red X's?
We have one yellow one, they're not referencing.
Right. Okay, so watch. I'll compile program, and I should get that same yellow X. Again, what that's telling you is it's saying you got a function set up, but you're not using it for anything. So if this was my final program, and I ended up not using a function, I would probably just take it out to make the code shorter and less, less stuff to read. Did you guys figure it out?
Yeah.
Good job. All right. So is everybody with me? Awesome. Yes, sir.
Do you want us to specify what seconds is yet?
No. See, we're going to do that right now. Okay. So now we have the two variables set up. We have our function set up. Now we're ready to write the program. So I'm going to start by just doing something very, very simple. I'm just going to reference that function. So I'm going to say run motor 4, and look, it automatically shows up. If you don't compile the program, it won't automatically show up like that. So you have to say compile. That's why I'm saying get in the habit of clicking compile. Okay. Also, it'll help you catch your errors right away, so you'll know exactly what you just changed and you click compile. So I'm going to say run motor 4, and then I have these parentheses. Now, I have to put something in those parentheses. What am I going to put in those parentheses, Ella? What does the function show? Run motor 4. When we go up there and we say void run motor 4, and then we have what is in there at the function level. Do you see it on your screen? No, you don't have it up? She's got it up. Float seconds. Okay, so when I go and I write and I use that function down in my code, and I write run motor 4, and then I have those parentheses, what goes in those parentheses? What? How many seconds? Exactly.
Excellent. Okay. So how many seconds should we run it for? 4 seconds? All right, 4 seconds. So I'll just put run motor 4 and then 4 seconds. That's a pretty short program, isn't it?
Yeah.
But that's a complete program. Watch, I'll click compile. We're all set. I would probably go in here and write some notes. This function will run Bob the motor for as many from parenthesis. I don't think I spelled that right. I'll just say. Okay. Yes, ma'am. What's your question?
I think it's that start motor is an undefined procedure, and I don't know why.
Okay. Start motor is an undefined procedure. It's probably because the language type on your platform type is not set to natural language PLTW. Okay. It is. It's under robot platform type, natural language PLTW. It's basically what it's saying. What you're doing is you're speaking a different language to it. It's not understanding because it doesn't know what start motor is. Okay, because that's like a different language. That's like when you guys say that's lit. I'm old. I don't know what lit means, and so you're speaking a different language. So I have to translate to middle schooler speak, right? Does that make sense? And if I switch into that code, then I know that lit doesn't mean like that it's that the candle is on fire because it's lit. Oh, it is? And that's what it means? No, it doesn't? Okay. All right. Okay. Cool. So we have this huge font size messed me up here. All right. Run motor for 4 seconds. Go ahead and let's upload that to the Cortex. So we'll take just a minute right now to compile the code, catch up, anything you need to do. Let's put it onto the Cortex. Go ahead and run it. Let's see if it works. Okay. I'll be around for any questions, and I'm going to leave this code up on the screen. All right. Oh, here's something you can do on your Chromebook. If you have, I don't know if we still have the the virtual worlds. If we still have the virtual world set up, then you can go to robot, compile, target, virtual worlds, and then when you say download the robot, it'll launch like that virtual world. You guys remember this, right? It's been in like all my login as guest. Sounds like some stuff's working. How's it going? Try unplugging it, try a different USB port. Why are you trying stuff?
I don't know what that means.
Common and improper coding, okay? That's going to have something to do with the fact that you have a role of this. Spelling is super important. If you misspell void, bold, you'll have issues.
Ours, it's good to run the
What does it run? Do you fix it to void and does it come out? Have you fixed it to compile it? See me setting up? Very keep on running into issues, but you're going to make sure that remember, the audio's still going on the screen. Where's your dead battery? Scott, plug in your dead battery. What? Scott, don't hold the battery that way, please. Hey, there's 2 batteries on that shelf right there. Those ones on good. Scott, right there. Scott, those. Awesome. Yeah. How are we doing on time? Yeah? What time is Wednesdays are different. No, what time is class over? Okay. I never remember. Okay, guys, we only have about 25 minutes. That's just enough time. Okay. Why is this not working? I'm all frozen up. Oh. What? Yeah. Pretty much. There you go. Where did that come from? That's kind of random. Okay. All right. Ladies and gentlemen, if I could direct your attention back to the code.
Yes, sir.
Raise your hand if you, it's okay. Raise your hand if you weren't able to get it to work. Okay. Just one? That's awesome. You got yours to work? Yeah. Okay.
All right, guys, we only have 25 minutes left, so I need to get through this, all right? We've got, from our list, we've defined variables, we've set up a function, and we've run motor for a certain amount of seconds. Now we need to use if-else statements, and I'm going to use the if-else statement, and I'm going to use the condition. If that happens, you can just turn the cortex off. Or you can just stop. You can just turn the cortex off. Okay? Okay, ladies and gentlemen, listen to me for a moment, please. Okay. All right. I'm going to say that I want my motor to run if it's bright or if it's light, right? So I want it to. So in other words, I want it to stop if it's dark. Yes, sir.
Wouldn't you put a sensor value line tracker, whatever you name your line tracker, to light threshold?
Yep. You're getting ahead. That's fine. So if, and then we're going to put our condition there, and then we're going to have these curly braces. You remember I said that I wanted you guys to put both curly braces? That will help us avoid those nasty red X's that are telling us there's an unmatched punctuation or something, okay? Now I can put in some line breaks, and I can start entering some code here. I'm going to get rid of my run motor for now, okay? So I'm going to say if, and then I need to have a condition, because my code the code for the if statement goes in there. The condition goes in here. I don't want to do that. Okay, what's the condition? Yes, sir.
Sensor value.
Just in normal language, what's the condition?
If it's bright.
If it's bright, right? So then what I can say is if, and we're going to find the sensor value. That may not be a command we've used before. If the sensor value, well, what sensor? And I'm going to use these brackets to define what sensor. The reason I'm using those brackets is that it's easier for me to tell the open and close and what things are combined into. You could use parentheses. The program would let you, but I prefer the brackets. Okay. All right, so the sensor, we called it Terry the tracker. So sensor value Terry the tracker. What about Terry the tracker? The sensor value is what? Well, we defined a variable called threshold. And so we're going to make the threshold the point at which we consider it light or dark. So I'm going to say that if it is greater than threshold, why is that not showing at up? Oh, I call it, because I didn't call it light threshold, I call it light threshold. There it is, light threshold. Okay, so if sensor value Terry the tracker is greater than threshold, then I'm going to do something. Right? I'm going to do something. What am I going to do? I'm going to run the motor, right? Right? So I can say run motor 4. Now, check this out. I'm going to do 0.1 seconds.
That's like short.
That is short.
Very short.
You know what? Let's take a step back. Let's just do 4. Let's just do 2 seconds. We'll do the point in a second. Run motor.
That's sorry, you said 2.
Okay, 3 seconds. Okay. 1, 2, 5. 1, 2, 3, 5. No, 4. You don't know where that's from, do you? Yeah, that's okay. All right. So run motor for 3 seconds, and then That's it, right? What's going to happen if I run this program?
It's gonna run.
That's gonna run. 4, 3 seconds.
Okay, let's go compile. Let's see.
Is that like threshold?
Download it to your Cortex real quick and try it out.
We got 3
We don't know.
Okay.
4.
We don't have a line for
You need to get one.
it. I think like you showed it on the camera and we never got that.
I can get you. I can get you.
No, I shouldn't do that. That's how stuff gets broken.
Can you help us? Can you help us?
What? What do you need help?
It's got 3 X's.
Okay. What do they say down at the bottom?
First one says left brace.
Yeah, you don't have the braces.
No, we do. But I really can get.
Don't trust mine, dude. You're gonna look at your own stuff, okay? Because look, then you probably, I don't even think, yeah, you got. Count all of your braces. You should have an even number of braces. Okay. Now, guys, when you click start, hey, listen up. When you click start on your program, it runs, right? If you cover up the light tracker, like grab it in your hand, cover it up, and then click run, did it do anything? Okay? So did it work? Okay. We need to keep moving, I'm sorry. Okay. Check this out, guys. When I want something to keep doing it over and over and over again, what do I call that? A loop, right? And so I can use a while statement. So what I'm going to do is I'm going to put this if statement inside of a while loop. So I'm going to say while, and the condition for my while is just going to be while 1 is equal to 1. And remember, I'm going to do those curly braces like that. And anything that is in here is going to run continuously. And it's just going to keep going. It won't even do anything below it. Okay? So what I need to do is I need to take that curly brace and I need to move it down below everything I want to be inside. Let me show you a trick. If I haven't shown you this already, there's a button that says Fix Formatting. If you click Fix Formatting, it does something, it indents things. So everything right here, you'll notice this curly brace is lined up with that while. This curly brace is lined up with that if. It's telling you that that's where that goes. So we're going to say while 1 equals 1, if the sensor value, light threshold, run motor for 3 seconds. If the value is true, it's going to run the motor for 3 seconds. Or if the statement or the condition is true, it's going to run the motor for 3 seconds. If it's false, it's not going to do anything. Now, for good measure, good practice, I'm going to use the else statement, and I'm going to put those 2 curly braces. And I'm going to say else stop motor, bob the motor. Okay? Else stop motor, bob the motor. Okay. Now check this out. This is kind of cool. What's going to happen here is it's going to check the value, and then it's going to run the motor for 3 seconds. But I don't want it to run for 3 seconds. I only want it to run if it's light. So if I cover it up, even if it hasn't been 3 seconds, I want that motor to stop. So I'm going to say run for 1/10 of a second, and that's fast enough for me that if it becomes dark, it's going to stop it. Because this is how the program is going to run. It's going to say, okay, while 1 is equal to 1, which is always, I'm going to do everything that's in here. I'm going to keep doing it over and over and over again. What am I going to do? Well, I'm going to say if and I'm going to check this condition to see if it's true or false. If Terry the tracker is greater than the threshold that we set, then I'm going to run the motor for 1/10 of a second. If that's false, I'm just going to stop the motor. I'm going to go back because I'm going to keep doing this, right? And I'm going to say, okay, I need to run this again. If Terry the tracker is greater than the light threshold, then I'm going to run the motor for 1/10 of a second. It's going to keep doing this over and over and over and over again. So if that is continuously true, the motor's just going to keep running. You're not going to tell that it's saying run for 1/10 of a second, run for 1/10 of a second, run for 1/10 of a second. It's just going to keep going. But as soon as that's covered up, if the motor had just been running for 1/10 of a second, as soon as it's covered up, it'll stop running. Okay? And that's as much precision as we need in this program. All right. So let's try that. Let's see what happens. Okay? You guys, let's go ahead and load it. Download it to the Cortex. Here, I can make my code a little bit bigger, I think. Yeah, you did it. Good. I see this will work. Excellent. Is it on? It's on. You got these plugged in the right spot. It looks like it's working. The name of the motor is bad. Let's grab somebody else's motor. Hey, yours is working. I'm going to test your motor.
Yeah, we gotta stop.
Awesome. Oh, why do you have the digital one? Is it the digital sensor? Not a digital sensor. Yeah. Okay, those learn early breakers, right? So, you got one early break. Did you forget the one after the L? You got the one after the if, you got the one after the L. You don't have the one after the while. So one more early break. One more closing early break. Closing early break. Okay? You can also just do Control Z. Hang on. Do a closing curly brace. Right. You can click it back. You can grab this right here. You can place it, automatically place it. One more closing curly brace right there. There you go. Yes. Yeah. Yeah, we 3D printed it. That's the original.
What's the 3D print? There's no springs in this one. Is anybody even watching the live stream? Does it say how many people are watching?
There are 3 people watching and you've got 5 likes.
Nice.
And you got 4 likes and 1 dislike.
Why does it work when I do it? Turn it off. No, it doesn't work when I do it. It does, no. Can we get a donut?
What?
Can we get that donuts now?
In a second. Yeah.
Are you using the natural language field?
Yes. Okay, last thing before I finish the stream. Last thing. Hey,
Two dislikes.
pause what you're doing with me.
What? 2 dislikes, 5 likes. 3 dislikes.
Who's disliking? That's not nice.
We didn't dislike it, we liked it.
It hurting my feelings. Okay. Hey.
It was Travis.
Okay. All right, check this out. One last thing. One last thing. What if I wanted this motor to run when it's dark and not when it's light?
Change the code. Then you change
Yeah, change the code, but what?
Change the sensor value.
Change the sensor value?
Change that to that.
Change that to that. Yeah, absolutely. So guys, one small change. Instead of saying the sensor value,
I think I did it.
hey, hang on. Hey. Are you guys listening? You're not listening. Taryn, please stop what you're doing. We're almost done. Okay. So the one thing that we're going to change, is I'm going to change that instead of greater than, I'm going to say less than. So if the sensor value of Terry the tracker, if he is less than the threshold, I'm going to run the motor. So if he's less than 2,000, I'm going to run the motor. Okay? Cool? Check this out. I got one more thing for you. You can set a variable based on sensor values. So if you guys notice in your debugger window for the sensor value, and if you don't know how to look at that, I'll show you that in a second. If you notice in the debugger window, the sensor value, when it's light, does anybody know what kind of value you're getting? No? Okay. So what you can do is you can say whatever the value is right when the program starts running, if you want that to be the threshold, then if anything covers it up, that value will go down, and then your motor will start running. That makes sense? So in other words, we say 2,000, we might not, that value, if we're in a darker room or if we're in a brighter room, we would have to adjust that value. We can get the program to adjust that value for us. So wherever you are, if it's really kind of dark but there's still some light, maybe the tracker will have a starting value of 1,000. And then if you cover it up, it'll be less than 1,000. Right? So we want to set the value of that variable to whatever the tracker is when we start our program. The way we do that is we say integer light threshold equals sensor value, Terry the Tractor. That's it. You guys give it a shot, try it, see if it works. And I'm going to copy all this right here, all this text right there, and I'm going to post it on IQ for everybody to see. Any questions?
We got like.
Okay, I'm going to go ahead and finish the stream. I think we're good. I think hopefully we'll see the quality once it's done. But hey, make sure you liked my video.
I did.
And when you go back to YouTube once it's posted, watch my video, just let it run in the background. That way we get lots of views and lots of likes. And if you have questions, put them in the comments. Okay? Okay. Cool. Thanks a lot. Hey, if you haven't subscribed, subscribe. And if you don't know how to get to my YouTube, remember you can just go to flip.school. 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 Thanks.